Here we have a list of the sine function properties. The standard sine function is y is equal to a sine b theta, where a cannot equal 0 and b must be greater than 0, and the absolute value of a is the function's amplitude, which, if you recall, is 1/2 the difference between the maximum and minimum points on that sine function. And b is the number of cycles in the interval from 0 to 2 pi, wherein 2 pi over b is the function's period. Now take a look at this guy up top, y equals sine theta. You can refer to that in the future as the parent function of a sine function. It's the parent function because the a and b that would appear here and here respectively have a value of 1. And since they have a value of 1, we don't actually write them into the parent function. You just see it as y equals sine theta. Once we transform that sine function by affecting the a and b value here, you'll start to see changes in your amplitude, your cycles, your period, that sort of thing. So remember, the top function y equals sine theta is your parent function, and then everything else is a transformation of that parent function. Now let's go ahead and work through a sample problem. Here's our problem. I'd like you to sketch one cycle of the graph y equals 3 times sine of the value pi theta over 2, and determine the period and amplitude of the sine curve. Let's begin by establishing what our a and b values are. Remember that the a value is what comes before the sine, the coefficient here, and in this case it's 3. So the absolute value of that number, so the absolute value of 3, is the function's amplitude. The absolute value of positive 3 is simply 3. So this function has an amplitude of 3. Remember, that's going to be half the difference between the maximum and minimum values of our sine function. Now we also want to look at b. b is the number of cycles in the interval from 0 to 2 pi. So we know that b is the coefficient that comes before our value theta. And if this is our value theta here, then what comes before that must be pi over 2. So pi over 2 is the number of cycles in the interval from 0 to 2 pi. So our cycles is equal to pi over 2. And 2 pi over b is the function's period, and b is pi over 2, so 2 pi over 2 is the function's period. We can't have a fraction in the denominator here, so I'm going to multiply by its reciprocal, which is 2 over pi. And this is going to change to 1 now. So we have 2 pi over 1 times 2 over pi. Our pi's are going to cancel. And we're going to get a period of 4 units. So our period over here is equal to 4 units. So now I can go ahead and graph this figure, since I know its amplitude, its cycles, and its period. Alright, so here's our graph. Now let's take a look at our amplitude first. Remember, we said that the amplitude was 3, and the amplitude is half the difference between the maximum point and the minimum point. So the maximum point on our graph is 3, and the minimum point is -3. And the difference between that is 6 units. Half of that difference would be 3, so that's our amplitude like we said. So we know that we can go 3 units up and 3 units down from the origin. Now our cycle number is pi over 2. Well, pi is 3.14 roughly, so 3.14 over 2 is 1.57, and we can just imagine that to be 1.5 to make it easier. So in the cycle from 0 to 2 pi, we're going to have 1.5 trips, 1.5 cycles. So 0 to 2 pi would roughly be 6.28 units, because 2 times pi, 2 times 3.14 is 6.28. So if this graph continued on to 6.28 along the bottom, if this were, say, 6 right here, then our graph would continue to go up and then curve back down, and so on and so forth as it went through the cycles. What we should expect is 1.5 cycles roughly from that point on the origin here to 6.28 right here. And that's exactly what you see. One cycle, remember, is just when a graph repeats itself. So when it gets to the point of repeat. this right here would be the point of repeat. So our cycle is from here to there. And you can see that we have roughly 1.5 of those if this graph is extended to 2 pi, or 6.28. Now also notice that our period is 4. The period is the horizontal distance of one cycle. And you'll notice, if our cycle began at the origin right here, when it hits 4, which is our period, it's completed one cycle like we just looked at. So hopefully now you have an idea of how to put a graph together based on a sine function. Now we're going to go the reverse. I'm going to give you some data about a sine function and ask you to give me the equation of that sine function. So what I'd like you to do is write the equation for the graph that has a period of 1/2 and an amplitude of 4. Well, let's begin with what we know. It has a period of 1/2, and we know that the formula to solve for the period is 2 pi over b is equal to the period. And since our period is 1/2, 2 pi over b must equal 1/2. So what we can do now is use the cross product property rule and cross multiply. 2 pi times 2 is 4 pi, and b times 1 is b. So 4 pi is equal to b. So that's the b here that's going to go in our sine function. Now we also know that it has an amplitude of 4. So the amplitude is our a value. So our a value here is equal to 4. So if we put all that together, we get a function of y is equal to 4 times sine 4 pi theta. Remember that this 4 in front is our amplitude, and this 4 pi here is our b value. So typically when given problems regarding sine function, you're either going to be asked to establish what the value is at a particular point in the sine function, whether it's in degrees or in radians, or you could be asked to draw a graph based on a sine function, or even to derive a sine function based on a graph. It's all fair game in dealing with sine functions, so go ahead and practice how to transform the parent function y equals sine theta into these different sine functions where it's y equals a times sine b theta.